Hello boys and girls and Stingray parents. Today we're going to take another look at the distributive property. This time though we're going to use the area model, and this will help graphically represent what we're doing mathematically with the numbers. Let's give a few problems a try, shall we? Boys and girls, let's take a look at the distributive property using the area model to help us represent it graphically. Now here we have a problem that's quite simple. It's 2 times the sum of 6 plus 24, or 2 times the sum of 6 and 24. And you've been taught to distribute the 2 to both of the terms inside the parentheses, which would look like this. 2 times 6 is 12, and then 2 times 24 is 48. And that is proper, that is good, that is correct. Now, how would that look graphically? Well, graphically, if we use the area model, I'm trying to get straight lines there, let's say that chunk of the area is 6, and this is 24. This area in here, and this area in here, and then we multiply it by 2. What does that do? 2 times 6, 2 times 6 would be 6 and 6, which is 12, and 2 times 24 would be 24 plus 24. And that would give us a grand total of 12 plus 48. But when I look at these numbers, especially 12 plus 48, I see that I can factor something else out. We're doing like reverse distribution when we factor. What can I factor out of the 2 and the 48 other than the 2? Well, I can factor a 3 out. And it would look like this. 3 times the sum of 4 plus 16. Okay, and 3 times 4 is 12, and 3 times 16 will be 48. We have the same thing, but we're setting it up as a different distributive problem or a different expression. So what would that look like? Okay, well, I have 3 over here, and this time I'd have 4 and 16. Okay, so this area represents 4, this area represents 16. So 3 times 4 and 16 would look like this. 3 times 4 is really 4 plus 4 plus 4. And 3 times 16 is really 16 plus 16 plus 16. And when I look at this, I see that I can do even more. Okay, let me move here. Let's slide this up a little bit, make some room. I'm not done. Let's try. Let me get rid of that. Okay. When I look at 12 and 48, I can also factor a 4 out. It would be 4 times 3 and 4 times 12. 4 times 3 is 12. 4 times 12 is my 48 again. Okay, well, let me get my box in here, my rectangle, to represent the area model. I have a 4 here. Oh boy. Let me erase that. Okay. Sorry about that. Okay, I think I'm good. Everything's good. Okay, so this would look like 4 right there, and then this would be 3, and this would be 12. Okay, and here's my line. So this area model here would represent 4 times the sum of 3 plus 12. Well, what does this look like? 4 times 3. Okay. These aren't exactly all even like how they should be, but 4 times 3 looks like 3 plus 3 plus 3 plus 3. Multiplication is repeated addition, and 4 times 12 would be 12 plus 12 plus 12 plus 12. And sure enough, we would have, once again, 12 plus 48. And I hope that was helpful, boys and girls. But here we can see this is the distributive property, and I'm using the area model to graphically represent what's happening with these numbers or how these numbers are being distributed. I will see you later. Bye-bye.